If you've met the skipgram model, then Cbow is its mirror image, and honestly the more intuitive of the two. Skipgram takes a single word and tries to guess its neighbors. Cbow flips that completely. It hands the model the neighbors and asks it to guess the word missing in the middle. It's basically the fill-in-the-blank game you played as a kid. The quick brown blank jumps over the lazy dog, and the model learns to answer fox. Why on earth would predicting a blank teach a machine what words actually mean? That's the beautiful part. Let's dig in. First, let's see what makes Cbow different from its twin. Its sibling model works in reverse. Skipgram takes one center word and predicts the context around it, which means every single word becomes its own little training example. That's wonderful for rare words because each one gets plenty of individual attention, but it's slower since you're making a separate prediction for every neighbor you look at. Cbow turns that upside down. It gathers all the surrounding context words, blends them together, and predicts the one word sitting in the middle. Because it folds many context words into a single prediction, it trains much faster, and it makes wonderfully efficient use of the common words that show up again and again across a big corpus. So how does one prediction actually happen inside Cbow? Let's follow it through one step at a time. Start with the context. Take a sentence and pick a gap. Say the quick brown blank jumps. The words on either side of that gap are our input, the clues the model gets to work with. Notice that we're deliberately hiding the middle word, because guessing it is the entire task. Now look up a vector for each of those context words and average them all together. This is where the bad part of the name comes from. Averaging throws away word order completely. So the quick brown and brown, the quick collapse into the exact same blended input. Simple and surprisingly effective. That single average vector gets fed into a classifier, essentially a layer that scores every word in the vocabulary. The network is being asked one direct question. Given this blurred together context, which word most likely belongs in the blank we left open? Finally, the model predicts the missing center word and compares its guess against the real answer, fox, nudging its vectors a little whenever it gets it wrong. Repeat that across billions of blanks, and here's the payoff. Those vectors it kept tuning along the way become the word embeddings we were after all along. Strip it all back, and 3 ideas define Cbow. It predicts a target word from average context. Hand it the neighbors, blend them into one vector, and it guesses the word in the middle. That fill-in-the-blank task is the entire training objective, and the embeddings simply fall out as a happy side effect. It's faster than skipgram on large corpora because it squeezes a whole window of context into a single prediction. Each training step does less work, and it makes excellent use of frequent words, so it really shines when you have a big pile of text to learn from. It's the other half of word 2vec, and it comes with a catch. Averaging the context and giving each word fewer targeted updates means Cbow handles rare words less gracefully than skipgram does. Like skipgram, it trains efficiently with negative sampling rather than a costly full softmax. All right, let's lock in what matters. Cbow is a core word 2vec architecture, and it learns embeddings by predicting a target word from the context words sitting around it. It's called a bag of words because it averages the surrounding context vectors together, ignoring their order, then feeds that average to a classifier to guess the missing word. Set against its sibling, Cbow trains faster and loves common words on a large corpus. But it's weaker on rare words because averaging hands each one fewer targeted updates than skipgram. Both halves of word 2vec train efficiently with negative sampling instead of a full softmax, And together they hand you a clean speed versus rare word quality choice. If turning dense machine learning ideas into plain English is your thing, we unpack a whole lot more of them over at standardy.com. Come learn with us.